Today I'm going to show you how to plot a nonlinear set of data. So if you look, we have a set of data graphed with graphical analysis, and we want to fit this to an equation. All right, so the first thing we want to do is make sure you always come up here first and do your calc options, or your column options, I should say, in seconds. All right, so time is on the x-axis, so you can see it's down here, x, because we don't deal with x's and y's in physics. We deal with columns and axes that are actual physics, not the general case, which is your y equals mx plus b that you've learned in math. So column options for the y, the vertical column is just going to be distance, and that's going to be in meters. Apply. So now you see we have distance and time down on the bottom. Right there, time. Okay, now this almost looks linear, but there's a couple things that are going to clue us off to the fact that it isn't. One, let's just plot a linear fit. Apply curve fit. So there. If I try to apply a linear fit, we might think, that's not too bad. It's close to all of these. It's a little below that one and a little below that one. Well, if we take this line, if we could just move it, which we can't, but if we could move it up a little bit, you'd see that all the data makes kind of an arc under it, or pretty much an arc. That indicates to us that it's a side opening parabola. Strike that. That indicates to us that it's a top opening parabola, not a side opening parabola. All right, another thing, you'll notice that I don't go from 0, 0 here. So let's go to my column or graph options. Let's start at 0, 0, where we're supposed to. All right. Now when we do that, you can obviously see that I have a huge intercept over here on the x-axis. So what that actually means is that this is not likely, again, going to be a straight line. It's going to be a top opening parabola. But it looks kind of flat at the very beginning, so it's really kind of hard to tell right off the bat sometimes what you actually have. So let's take a look at plotting the right shape in here. So if you go to the sheet that tells us how to modify our data, we know that we have to modify time squared. All right, whatever's on the x-axis, square it. So we're going to come up here. We're going to select Add Calculated Column. Our calculated column is time squared. And our units are meters, and we'll just go raised to the 2. Then we're going to insert the expression. Almost always we're going to use one of these two. So we want a x raised to the b, where a is just going to be a constant 1, and b is going to be 2. So if we insert that, there we go, it already selected it for us. A, column time, and squared. If the right column's not up here, you can just change it. But we want that column. So apply. All right. Let's get rid of this fit. And let's try to use our new time squared column. So to use the new time squared column, we're going to select down here and time squared and distance. Every time we put in a new axis, we have to go back to the graph options and fix our 0, 0 point. And then we would also want a title here. All right. So enter. There we go, distance versus time squared. We see that this is going to be nice and linear now. So let's apply a fit. Linear, apply. And you can see Now we have an equation right here. Y equals mx plus b. It goes through almost all the data points. Looks great. Now, one of the things we want to do is we want to actually have an equation that's in terms of physics variables, not our general math equation, which is y equals mx plus b. Because we don't have x's and y's on our axes anymore. We have distance and time squared. So here's how this is going to work. So we know the general equation is y equals mx plus b. Well, if we come over here to y, that's distance. So I'm going to insert another thing here. Whoops. I'm going to add an annotation. I'm going to move it. Well, I'll move it after I finish. So I'm going to say distance is equal to, so y equals m is my slope right there, which is 2, times x. Well, x down here is time squared. All right, and then I look at b. B is my y-intercept. It's 0 or oftentimes very near 0, and so we can ignore it and then just enter. We're done. So distance equals 2 times squared. I can put that right under here. There's my equation. All right, let's talk a little bit about presentation. So to present this graph in a report, I've had you cut and paste it or take a screenshot. Here's a couple of tips for you when you do that. So first of all, if we come over here and we go presentation, we can increase the size of the text a little bit. Makes it a little easier to read. There we go. Whoops. Now we got to move this around. Okay. This just moves up and down, but this guy I can move anywhere. There we go. All right. So now it's a little bigger. The other thing we can do is if you click this guy, we can show just one graph. We can get a screenshot of this and insert it into your report.